晓，天和地对接信号，等待破芽的野草，是时间随手抛下的锚。空无一物，淡出奇妙，把惊喜装进被套。要和世界对暗号，才交换彼此的密报。地踏是夏天娱乐，傻傻是晚风，悄悄是水蒸放是我的美梦。准备上空，刀光过于某种，日出穿透我摔的眼眸。整个世界，所有声音在视线上跳动，尽情伴奏属于我的与众不同。空无一物，淡出奇妙，把惊喜装进被套。要和世界对暗号，才交换彼此的密报。不老是大海淌着，粗粗是凌波，普通是遇见他是我的心动。准备上空，刀光过于某种，日出穿透我摔的眼眸。整个世界，所有声音在视线上跳动，轻轻伴奏属于我的与众不同。只想这辽阔宇宙，星星领着我，放声唱歌，播放我的自由。准备升空，刀光过于路中，日出穿透我摔的眼眸。整个世界，所有声音在视线上跳动，轻轻伴奏属于我的与众不同。啦啦啦啦啦啦啦啦，啦啦啦啦啦啦啦啦啦，哒哒哒哒啦哒哒哒啦哒哒，哒啦哒哒哒啦啦哒，哒哒哒哒啦。一朵云带一场云霄，天和地对接信号，等待破芽的野草，是时间随手抛下的锚。空无一物，淡出奇妙，把惊喜装进被套。要和世界对暗号，才交换彼此的密报。地踏是夏天娱乐，傻傻是晚风，悄悄是水蒸放是我的美梦。准备上空，刀光过于某种，日出穿透我摔的眼眸。整个世界，所有声音在视线上跳动，轻轻伴奏属于我的与众不同。空无一物，淡出奇妙，把惊喜装进被套。要和世界对暗号，才交换彼此的密报。不老是大海淌着，粗粗是凌波，普通是遇见他是我 上跳动，尽情的走，属于我的与众不同。这向着辽阔宇宙，星星领着我，放声唱歌，播放我的自由。准备升空到广阔云雾中，日出穿透我帅的眼眸，整个世界所有声音在视线上跳动，尽情的走，属于我的与众不同。一朵云带一场云霄，天和地对接信号，等待破芽的野草，是时间随手抛下的锚。空无一物，淡出奇妙，把惊喜装进被套。要核实这对暗号，才交换彼此的密报。地踏是夏天日落，沙沙是晚风，悄悄是水蒸放是我的美梦。准备升空到广阔雨幕中，日出穿透我帅的眼眸，整个世界所有声音在视线上跳动，尽情奔走，属于我的与众不同。空无一物，淡出奇妙，把惊喜装进被套。要和世界对暗号，才交换彼此的密报。不老是大海淌着，粗粗是凌波，普通是遇见他是我的心动。准备升空到广阔雨幕中，日出穿透我帅的眼眸，整个世界所有声音在视线上跳动，尽情的走，属于我的与众不同。这向着辽阔宇宙，星星领着我，放声唱歌，播放我的自由。准备升空到广阔雨幕中，日出穿透我帅的眼眸，整个世界所有声音在视线上跳动，尽情的走，属于我的与众不同。 Wow. Sorry for the delay. Something came up right after I selected the star. Oh, the window is not catching up here. Hello, Simone. Hello, Arn. Today gonna continue doing some interviews, questions. Starting off, the first question is next permutation. A permutation is an array of integers is arrangement of its members into a sequence or linear order. For example, array 1, 2, 3, the following are subpermutations 1, 2, 3, 1, 3, 2, 2, 1, 3, blah blah blah. The next permutation of an array of integer is the next lexicographically graded permutation of its integer. More formally, if all the permutations of an array are sorted in one container according to a lexicographical order, then the next permutation of the array is the permutation that follows in the sorted container. If such arrangement is not possible, the array must be rearranged at the lowest possible order. For example, the next permutation 1, 2, 3 is 1, 3, 2. Similarly, the next one is 2, 3, 1. 2, 3, 1, 3, 1, 2. Given an array of integers, find the next permutation of numbers. Array of integers, next permutation. And we have a constraint that it can only use constant extra memory, which means if we do use any variable to store the data, it must be a constant variable. Replacement must be in place. So if we look at the examples, 1, 2, 3, the highest value is moved ahead 1. And 3 to 1, if we move the highest value to left, because there's no left, that means it pushes 1 back. But in that case, it will be 2, 1, 3. So basically, we need to find a pattern. So between example 1 and example 3, I think the pattern is you find the largest number and then you shift that largest number to the left. And number 2 is the largest number is the first number. How does that work then? If the largest number is first number, then we rotate the whole array. Is that the... The constraint is number must... The number is between 0 and 100. That means there's no negative number in there. Let's see. If we take this example 1, 3, 2, if we do the... Based on the logic, we move 3 to left. So 3, 1, 2, which is not correct. This game is a little hard for unaware people. The good part is that you actually know. I think the problem right now is I don't know. I'm also stuck right now. If all the permutation of array are sorted in one container according to the lexicographical order, then the next permutation of that array is the permutation that follows it in the salty container. Lexicographically graded permutation. What does this mean? Lexicographically refers to a method of ordering a sequence, typically string, based on the alphabetical order in their component elements in mathematics, computer science. Generalization of alphabetical order, where the sequences are compared by element from the left to right, similar to how words are arranged in a dictionary. Hypo is considered less than banana because A is before B. That doesn't help me. Primal, yeah. I'm using a... My system... Okay, my system theme is dark mode. Right, so if the browser is smart enough, it should follow my system theme. Although, like, whenever I change the theme mode, I'm using a incognito mode. So I think like whenever I switch over, whenever I start a new incognito, it just it goes back by default. But I think like if the thing is smart enough, they should follow my system order. And my system is always dark mode. Okay, 1, 3, 2. Oh, between these two, you have 3 letters. The next there's no next. Okay, I think I have an idea. One, 2, 3, 1, 3, 2 is bigger than 2 because you compare the initial value and then you compare the second value. If they're the same, then you compare the second value. And whichever is greater is the next permutation. So then that means they should be in my brain pain. My brain is also pain. If we find the largest number, and then we find the second largest number, we swap the two numbers. That doesn't work. Because in this case, if we swap, this just goes back. If the largest number is to the left of the smallest number, I mean, if the larger number is up to the left of the second largest, then second largest swap with the first. That's not how it works. We can test that by 1, 2, 3, 4. Let's say 1, 3, 4, 2. In this case, the next permutation we're looking for is 1, 4, 3, 2. Right? So if we look at the largest number and the second largest number is to the left of the largest number, then we swap these two. Actually now think about it, this might be working. So if I do 1, 4, 3, 2, what we're looking for is the next biggest is in this case, it will be 2, 1, 3, 4. Oh, this is hard. The next biggest will be 2, 1, 3, 4. It'll be easy if we can. This will be easy if we can use a stack and then we'll just compute all the permutations and we look at the next one. But the problem constraint is that the replacement must be in place, meaning we can only modify this. And we can only use constant extra memory, which means we can only store values as a constant. We can only store constant amount of variables. And if we use a stack, the stack size will be the length of the nums. So which breaks the constant. So I just need to find the pattern. Then that can find the next one. The brute force, we can find out every possible permutation by possible list formed by the given array. I find out which one is larger given than the given one. But this one is very naive approach since it requires us to find every possible. That's what I described, which takes very long time for the implement. Thus, this approach is not accepted at all since we moved to that direction. Next one. Okay, let's see. Single pass approach. First, we observe that give any sequence that is in descending order, only no next larger permutation is possible. For example, no permutation is possible with the following array. We need to find the first pair of two success number. Wait a minute. Hold on. If you look at this as a monotonic stack, so each next value must be greater than the previous value, right? So when that breaks, this is the one that breaks at this location. So once that breaks, we swap these two. And for the next one, if it's in decreasing, if it's in must be increasing order, then the first one that breaks is here. What can we do about this? This one that breaks. According to that logic, we should swap these two, which is not correct. We need to find the first pair of two successive numbers from the right, which satisfy AI is greater than AI minus 1. Now the no arrangement to the right can create a larger permutation since that substring consists number of decreasing order. Thus we need to rearrange the number to the right, including itself. Now what kind of rearrangement will produce the next larger number? We want to create the permutation just larger than the current one. Therefore, we need to replace the number AI minus 1 with the number which is larger than itself among the numbers lying in its right. Okay, so in this case, I say I is this, A is this, I minus 1 is 4. So 2 is less than 4. So we go to the next one. 3 is less than 4 is greater than 3. So we swap these two, which will be correct. But if you look at this example, this is smaller, greater. And we need to swap the... And you cannot swap these two because this will break it. We solved number 8, I minus 1 and 8j. Replace the number of AI, which is the number just greater than itself among the numbers lying to its right section. With smaller permutation that can be performed by using the numbers only to the right side of AIJ. Oh, this is 4 is here. Is that right side of the smallest? Using numbers only to the right side. Smallest permutation only to the right side. So 3, 4 to the right side. Wait, hold on. This is a larger. Oh, to the right side there's only 2. That still doesn't make sense. Recall that while scanning the numbers from the right, we simply kept decreasing the index until we found AI and AI minus 1, where AI is greater than AI minus 1. Also number to the right of AI. Wait, until AI is greater than AI minus 1. So the right side is greater than the left side. Until AI is greater than AI minus 1. So this is greater than this. Thus all the numbers to the were already sorted in decreasing order. Furthermore, swapping Aij and Aj didn't change the order. Therefore, we simply need to reverse the number following AI minus 1 to get the next smallest lexicographic permutation. You look at this number, this is the number that's decreasing. So look at that, swap, and then reverse. Wow, are you kidding me? So in this case, we start traversing from the right side to the left side until we find a decreasing order. So in this case, this is increasing and this is decreasing. We find a increasing order, and then we look back to the right side. We find the next value of the right side. Then you swap these two values. After you swap these two values, it will be 3, 2. Oh, this should be actually 2, 3. After you swap these two values, you reverse the whatever that's remain. So in the next case will be 3, 2. We look at that. We find the decreasing order. And then, so this is I minus 1. You look at the right side, you find a larger number than this, which we cannot find. If we cannot find that, what do you do when you cannot find? Help! So we need to find a larger number than this. Oh wait, hold on. Decreasing order. Decreasing order is this one. So 1, you look to your right side. You find the next larger number and you swap. So find the next number, you swap. So it becomes 2, 4, 3, 1. And then you use starting from that index, you reverse the remaining numbers. So that becomes 2, 1, 3, 4. And the reverse part, since we can only do this in place, we can take the first element. I mean, we know the length of this because we know the index of this. So we take the first element, we move it to the back, and then next we take this element and move it to the back. That's how we reverse the order. Even if brains to understand questions now, yeah. That's how you need to get to a fucking... This is what you need to get a fucking jobs nowadays. Okay, so to start, we need to look from the... So let I equal to nums.length minus 1. I is greater than or equal to 0. And I minus minus. So we're looking for decreasing order. Actually, this should be greater than 0, since we are always looking 1 numbers ahead. So we are looking for decreasing orders. That means nums I must be greater than nums I minus 1. If we do that, then we found the decreasing order. If we found the decreasing order, that means we need to look to the left side. So for let j equal to I minus 1, j plus plus, j less than nums dot length, j plus plus. So we're looking for the number that's looking for a number that's just greater than greater than I minus 1. So we can let the smallest number to be nums I minus 1. Actually, no. We know I minus 1. I minus 1 is always gonna be the smallest. We are looking for a number that's just greater than I minus 1. So we can assume that. So we just look for Okay. The thing about this, we only need to look for the next biggest number. So there could be like the next bigger number. There could be even bigger numbers to the right side, but we only care about the next bigger number, which means to the right side, the bigger number should be the smallest number that's greater than the current value. Alright, so we can start from I. If we can less. Okay, remember the constraint here. Constraint is that the number is starting from 0 to 100. So if we set the next value to be -1. So if nums j is greater than nums I minus 1, and it's greater than I minus 1 and well, I think we don't even need to do next here. We can set a next equal to nums I and nums j is greater than max. If we found that, then we set the next to the nums j. So by the end, after we're done with this loop, we will have a next, which is the next biggest value after I minus 1. And after that, oh, we need the index. So let next equal to I. And then nums next. And then next is equal to j, where is the index. So after that we have next. And then we have this number. We want to swap these two numbers. So nums I minus 1, and then nums next. We should remember I minus 1. Actually, no, we don't need to remember because we already know I. So we already know I. After that, we can swap these two. Nums next, and then nums I minus 1. After we swap these two, we need to invert the remaining numbers. So in order to invert the remaining 4, we do this again. Let j equal to I. A less than nums of length. A plus plus. So we take the first value that we see. We push it to the end. For this, until we hit the last value. So we shouldn't touch the last value. So nums dot splice. The starting index is j. Let me double check. This is very easy to get messed up. JS remove value from one array. Splice, yeah, splice. Splice index 1. Starting that index, you set 1, you only remove one item from that index. Right, so splice, I supply in the index, and then I want to remove one value from the index. After I remove that one value, I push it to the end. Non-push, splice j1. Splice j1. This should return, this value should return the 2. So we do this until we hit the last value. After we're done with that, then we just break it out. Run this. Wrong answer. We actually got 2 cases correct. Let's see. 3, 2, 1. 3, 2, 1. And what they're looking for is 1, 2, 3. Oh, this is the special case where there is no this special case where there's no there's no value that they found. So we're looking for these numbers. Each traverse all the way to num length -1. Else if so the last element that we should be looking at would be num I should be equal to 1. That would be the last element that we're looking at. So if I is equal to 1, that means we hit the beginning, and we haven't found something that's greater than, which means everything to the left side is always in an increasing order. Just like in this case, everything to the left side is in increasing order. Oops. That means we need to reverse the entire string. For reverse, we can do the same thing. Let's break it up to function. Reverse. In order to reverse, we just need to know the index. Right, so index. And we can take this piece and slap it here. And instead of I, we just need to do index. So reverse index, which is reverse from I. So in this case, we do reverse, and then we supply them with I. And in this case, we also do reverse, and we supply with I minus 1, since we don't want to start from the beginning. Actually, we don't even need to do I minus 1, just do 0. Because we know it's gonna be starting from 0. So run this again. Undefined is not a valid. Reverse index. Non-push, non-side J. Index high. So reverse 0, 0, J is 0, J less than non-length minus 1. Non-splice 0. We take out the 3. We push it to the end. That should be it though. No? If I cancel out this and run this again, this should still work. So the problem is reverse at 0. Non-splice 0. Why can't I reverse at 0? Else if I is equal to 0. I think I don't even need to do the else. If I is equal to I equal to 1, that means I have hit the end. So run this. I. This is gonna return something because it never hits. It will never hit 0 because we have the condition I greater than 0. So how can reverse when 0 is not working? the reverse from 0, num spice. J is 0, starting from 0. So one value from starting from 0 is 3. We take 3, we push to the end. And then we take 2, we push to the end. J less than num.length. Nums.length minus 1. Nums.length is 3. Minus 1 is 2. J less than 2. This is 1. So we do one more again. Oh. But even it does that, it shouldn't matter. Why did that? How about instead of reverse, I just do a sort. Nums.sort. This is same error. I feel that the only problem is this. They may have a better way to do this, I guess. So they have a reverse function num as star. The reverse function passing num. The reverse function they're using passing num. The star follow I to j while I is less than 3 swap num. Oh, so the type of reverse they are doing. In my case, I'm doing the array modifications. I mean, I'm doing like removing the value from the array and then reinserting the value back to the array. And what they are doing is just swapping. Okay, we can also do that. So reverse num and then star list star if we know the star, we don't care about anything else. So we're swapping star and n. So let n equal to nums dot length minus 1 while star is less than n. We're gonna do swap. So swap num star nums n to nums and nums star, and then we do star plus plus and n minus minus. I don't think we need number. We just need a star. We can test this. If I run this to be correct, so we can do reverse from 0. Correct. Submit. It's wrong. Okay, this is not doing what you want to do. So 1, 3, 2, they're expecting 2, 1, 3. So let I equal to num length minus 1, I greater than 1. So I is here. Since we're looking for next decreasing value, so I is not greater than I minus 1. So next, O if I is else. I thought the break would do that. Yeah, it's not doing it. So 3. Num I is 3, I minus 1 is 1. So 3 is greater than 1. So next is equal to I, which is 1. And then we find the next greater number. Well, is it? If I set next to minus 1. If I set next use this case. Use this case, and then I'm gonna remove this bar, just so it doesn't mess up the calculation. And then I submit this. Case 4 is now also fail. And now we know that this doesn't matter. So you know that this next is I minus 1, which is 0. So let j equal, this j, this j equal to I minus 1. Case 4 is still wrong. J equal to I minus 1, which means j is 0, j less than number length, j plus plus. If num j num I minus 1. Okay, we take this value looking for the next biggest value. So num j must be greater than I minus 1. In the first iteration they are equal. So skipped. And next, this is greater than. And also greater than. So we set next to j, which is 1. One thing we're looking for the smallest value. Now this is wrong. If I set this like this again, that's correct. Okay, so this is just the order is wrong because we're looking for the next smallest value. Submit this. Now this is wrong. Fuck. Two, 3, 1, 3, 3. And we're looking for 2, 3, 3, 1, 3. So I is 3. And I minus 1 is 3. Skipped. Next I is 3, I minus plus 1. So I is greater than minus 1. We set next to I, which is 3. So we do that, we look for j is I. We're looking for a number that's greater than. But I is index 0, 1, 2, 3, index 3. So we're looking from index 3 to index 4. and j less than number. If num I, num j is greater than num if j is greater than num I minus 1, I minus 1 is 2. So which is 1. This is 3. And 3. So j is greater than I minus 1. And j is less than well, it doesn't matter because I already set next to j and j starts at j. So j is still, in this case, j is set to 3. If j is less than next, 3 is not less than 3, so nothing changed. Next is 3. 3 is bigger than 1, but 3 is not less than 3, so nothing changed. So in this case, next is still at 3. So now we swapped I minus 1, which is 1, and then next is 3. So we swap these two values. After we solve the two values, we want to reverse the remaining after we swap it's doing its job. After we swap these two, we will reverse this so it becomes now it's this. Right, that's exactly what they are fucking doing. And look until it's next biggest, then you reverse. But these two are the same. If they're the same, if I keep this and they're the same, so I'm only swapping the last element that I see that's just bigger than the number that I want to swap. So if I do this, then swap back, then it should be correct. Run this. Okay, case 3. No, submit this. Holy shit! Oh my god. I need to complain. Okay, guys, I need to complain a little bit. The guy said the guide said you need to swap the next biggest value. So I look for next biggest value, and then I swap there and then do an invert. But they actually should say you look for the next biggest value if there are multiple duplicates. of the next biggest value. Then you swap the last element of the next biggest value. And then you invert. So the only thing different was that I was just inverting the first of the duplicate, where they want us to invert. I only swap from the first of the duplicate, where they actually want us to swap the last of the duplicate. So that's the only difference. Fuck. Do I use ChatGPT or LLM? What's LLM? Large language model? What do you mean? Like, ChatGPT is a subset of LLM. So your question is like, do you want Fuji app? Do you use Fuji Apple or Apple? That's your question. So it makes no sense. Okay, next. Fuck, this take way too long than I want it to be. Let's find the next question. Next question. Wait, I was looking at something earlier and I cannot find it anymore. Because I was looking at discussions about some company, and some people said they seen this kind of that they seen a question from that certain company. Oh fuck, I hate that this Leetcode. You cannot see that because I don't want to spoil you that certain company yet. So whenever I refresh, the sorting refreshes, which is annoying. Oh, okay, here. I actually got this question in one of the interviews before. Here's another median question. So, binary tree right side view. Given the root of a binary tree, imagine yourself standing on the right side of it. Return the value of nodes you see ordered from top to bottom. So, assuming that you as a person is standing to the right side of here, like this is the person, and you look to your left, this is what you see: 1, 3, 4, because 2 and 5 is blocked by 3, 4. Right, so here another binary tree, you can see 1, 3, 4, 5 because there's no nodes to the right or left of 3. Right, so this is a kind of simple binary question. We can just do it with breadth first search. Because breadth first search, we're gonna traverse level by level. So we look at the first level, and we return the end of the level, which is 1. We look at the second level, which is 2 and 3, and we return the end of the level, which is 3. We look at the next level, 5 and 4, and we return the end of that level. So, by the end we hit all the levels, we should be able to get a list of views that we see. Okay, so the standard breadth-first search is we start with a stack that on stack equal to, we set the root node to the first of stack, while stack.length. We're gonna do a const size equal to stack.shift. So we take the root node, we put in the stack, and then we take out the root node. So for net I equal to 0, I less than size. We are doing this because we will be modifying the size of the stack. So if we keep modifying and then we're looping through this could be an infinite loop. So I plus plus. If so, we're looking for the end of the current. Wait, oh, it's not shift. Stack.length -1. So how we know it's the end of the current stack is if I is equal to size -4. Actually, no, -1. I is equal to less than or equal to size. So if I is equal to size, that means we are at the end of the stack. So we can do a, let's see, response equal to new string, new array. And if we found that, then we just push that to the response. Response will be const node equal to stack.shift. If I is equal to size, then we push the node. Right, so next is just the standard stuff. If there's node.left, then we stack.push node.left. If there's a node to the right side, then we push to the right side. So last 3, we just return the response. Emit error is not valid because the type. Oh, do they want to know top value? Emit. Cannot read property of no. Okay, I equal to size. I less than size. So size -1. Submit. Time limit. We push 1 to the stack. Size equal to stack dot length, which is 1. I less than 1. No equal to stack dot shift, which is 1. If I currently at 0 equal to size minus 1, so 0 equal to 0, we push no dot value. This dot value is returns value, right? Why is it wrong? Boom. So no is equal to stack dot shift. Stack dot shift is 1. I is equal to 1. Push that, okay? So at 1, I less than 1. Stack dot shift. I is 0, size 1 minus 1 is 0. So no dot push value. Push value. And if there's no dot left, we push no dot left to the stack, which is 2. And if there's no dot right, so we push that to the right. And then next, size equal to stack dot length, which is 2. I equals 0. Right? Stack dot shift. Remove 2. Is I equal to size minus 1? Size is 2, I is 0, 2 minus 1 is 1. So respond to dot push no is not happening, so no dot left, nothing. No dot right is 5. And then we go to the next value. Next value, no is equal to stack dot shift, remove 3. So I is equal to size. I equal to size minus 1. I is currently at 1. Right? Size is 2. 2 minus 1 is 1. So respond dot push no dot value. We push no dot value, which is 3 in there. And then we look at no dot left, nothing. And look at no dot right. It's 4. So next iteration, size is equal to 2. Right, so looks fine to me. If I equal to size minus 1, respond dot push no. Oh well. So next song will do the same thing. You pop 5. There's nothing to the left, nothing to the right. and it's less than size. Next we pop 3. We pop 4. We pop 4. Now size is 2. I is at 1. Size minus 1 is 1. So you push 4 to this here. And you look at left, there's nothing left. You look at right, there's nothing right. And stack now is empty, so we return response. It looks right to me. It looks right to me. Why is it? Why is no? Why is no? We initialize stack as the root value. So stack.shift should return the root value. So we console log the root value, and it's no. What the fuck is going on here? Let I equal to 0, I less than. Size I plus plus. Also log stack. Why is stack no? Why is the stack no? What the fuck is going on? Console.log stack. Why is stack no? Oh, row is nothing. Expect the input if okay. So this special case is row dot length. If there's no row dot length, then we just return nothing. If there's no roots, return nothing. Holy shit! I should have just read the fucking input that, like, at the end it was the input that is showing. Submit. Yay! So I was looking at all the. You see, I was looking at all the possible inputs and trying to figure out why this input doesn't work. And then I realized the fucking input is actually just an empty array. So I should have just look at the input at the end. So yeah, I suffer from the Yu-Gi-Oh player syndromes where I don't read the problem. Anyways, yes, I should take a break. So my whole algorithm is correct. However, if they supply a like nothing, if they supply nothing, because breadth first search requires you to have a stat to start with, and if you start with nothing, you get nothing. Basically. Anyways, time for break. See you guys later. Bye bye.朵云带一场云霄，天和地对接信号，等待破芽的野草，是时间随手抛下的锚。空无一物，淡出奇妙，把惊喜装进被套。要核实着对暗号，才交换彼此的密报。地踏是夏天预料，傻傻是晚风，悄悄是水蒸放是我的美梦。准备上空，刀光过雨墨中，日出穿透。